So this way, I'm going to share this video on YouTube and then onto Classroom for you guys. We're going to go over just one example of solving a polynomial equation, and the directions I always like to write down. So it might just be as simple as the word solve. They might not tell you that it is a polynomial equation. That's sort of for you to recognize. So we have 12x to the 6th power plus 19x to the 5 minus 43x to the 3rd equals, so equal sign is a big indicator. Like if the directions, say you forgot to write them down, or if they were ever like missing off of a worksheet for some reason, the fact that you have an equal sign, and we spent many discussions talking about this, tells you have an equation and not an expression. So when I walked around the room yesterday, for those of you who were at school and were working on this, what happened was some people, what they do is, you kind of work off of muscle memory, and people, they did get it equal to 0, but then they factored and stopped. So if it was an expression, something like that with no equal sign, and the directions could say factor the following expression, and then you stop. So that's like the early stages. But we say solve, we have an equal sign, you're going to get x equals at the end. That's how you know you're done, okay? So first step for solving any equation, especially a polynomial equation, what is the first thing that you should try to do? You can say it in chat out loud. You don't even have to raise your hand, just yell it out in the chat, okay? Right, we want to get everything equal to 0. So a place where people tend to mess up is I know, to subtract from both sides. But those of you who kind of like don't show your work and you do it in your head, and I get it, a lot of times you can, but the more complex any type of problem gets, think about your computer, right? I've used this analogy before. If your computer has too many things open, you hear the fan turns on, it starts like breathing heavy, it shuts down, it freezes. Literally, you guys, you freeze on a test. Right? Maybe you start breathing heavy. You get really hot. You literally behave like your computer does. So you mess up silly little operations because you're doing too many things at once in a higher level thinking problem. So write it down. It's not going to kill you. All right. Add this guy to both sides. A lot of people, they started this correctly, but then they accidentally subtracted that from that side. If you add to the right, we all should hopefully you would also add to the left. I want to try to stack things underneath their counterpart, and then minus 117. So obviously in the next few minutes, seconds, I'm going to ask you guys like, what's this plus this, what's that plus that? So you guys could just type it out in the chat, or you can, say it out loud. Even if someone says it already, still type it in the chat. Like I said earlier, it lets me know that you're paying attention. So I want to do minus 117 x cubed. I'm going to put that one above here. Doesn't really matter where I stick it. Is it clear for most of you guys, the screen? You could nod if you could read it clearly. Okay, thank you. Next, adding everything and keeping it in order, combining my like terms. So the first term's pretty good, 12x to the 6th. The second term, what do we get for our coefficient for the x to the 5th term? Nice. And what about for, x to the 4th, I only have that 64. And what do I get for my coefficient for the x to the 3rd term? A little awkward. You have two negatives. It's 117, 43. I would think of it, the 3 added on to that first, and then 40 more. So I see in the chat, nice. So it's minus, and the 160 x to the 3rd. Good. Okay. Now, new beautiful line. We forget that. We're good from here. We pick it up from here. Again, what's the goal? Solve. How many answers is the maximum number of answers you might get for something that looks like this? Good. At most 6. It doesn't mean you have to have 6. Here's another little piece of advice too. So we did do graphing already. When we first did this section, we didn't graph yet, right? Like this was lesson 12. When you graph this, if it were this whole equation, what would your end behavior be? What would the end behavior be for something like this? Good. Up and up. Yeah. So up and up tells me that it is possible, if this is the x-axis kind of over here, pretend, it's possible your whole graph is above the x-axis and you actually end up with 0 answers. That's a possibility, right? If you have an odd, like if this was x to the fifth and it was down on one end, up on the other, you'll have to have at least one answer, because there's no way to be down and up unless you pass the x-axis. And the x-intercepts and solutions to a solving equation are basically the same thing, all right, for the most part. All right, so continuing anyway. So we could have at most 6. After you get it equal to 0, what do we do next? Out loud or in the chat. Next goal, ooh, nice. We look for a greatest common factor, which is one of the methods of factoring. So we definitely want to factor GCF, best way to do it. So who was it? Tara and Clem, when you were like, I know I have to find a great, was that you girls? When you're like, I know I have to find a GCF and I think I find one, but no, like it's not the greatest, right? Was that who it was? I forget who said that, but yeah, that was okay. So yeah, so looking at these terms, just take it slow to yourself. 12 is kind of the smallest number. So some people might think like, I'll pay attention to the 12. I would also pay attention to 64. Do you guys remember what number to a power other than like 8 squared? What else equals 64 as like something to a power? Good. And what else even smaller to a power? Nice. No, you got it. 2 to the 6. So that's 2, 2, 2. So the fact that 64 is one of the things we're looking for GCF on. The fact that 64 is only made up of 2s. Your GCF could only be like 2, 4, 6, not 6, sorry. 2, 4, 8, 16, or 32. It could only be something like that for like something that they all have in common. So 12 has how many 2s in it? 12 has 6 2s in multiplication. I think you're adding. Yeah, no, you're adding, but it's all right. So that's 2 times 2 in there, right? How many 2s are in 30 though? Do you have a 4 in 30? 30 is 2 times 15, which is 253. So only 1 2. So that means my GCF has a 2. That's it. And how much x? Nice. Good, good. X to the third. All right. So after we take that out, you're going to tell me what terms are inside. So you want to type one of them in the chat, type the last one, the third one, second, first, whatever. Just let me know you're here. But I'll do the first one, I think, would be how much x to the third. If I only took a 2 out. Yeah. 6x to the third. Good. Then kind of keep going. Next coefficient, it looks like a 15. X to the second. And we see how like people are typing, Gabe and Lucas, they type the exponents that way. Ooh, I see someone up there using actual exponent. Jackson, nice job. Minus, that's going to be 32. X to the first. And then minus, how much is half of 160 is good. All right, now, next point in the problem, again, use your eyes. Don't underestimate them. What factoring method looks like what you would want to apply here? Beautiful. I would guess grouping 2. All right. So what's the greatest common factor out of the first 2 terms? 3, yeah. 3. The first 2 terms, for whatever reason, I feel like it's always a little easier to do the GCF here. And then when you guys get here, it gets a little awkward sometimes. So we'll go over that little trick. And then that should be x to the second, right? Jaya, question? Oh, see? You perfect. 3x squared. And what's left inside? Amazing. Good. And I see a couple of you got it in the chat too. Perfect. So when you're confident about this first part, some of you needed to be reminded when I was walking around yesterday and you're like, I don't know what the GCF is for this. Remember, whatever ends up being the GCF, I'm just going to grab like a highlighter over here, that you take out of, those 2 terms that gets written over here. If all is working out smoothly, what should be in these parentheses? Right. So you basically are going to do it the cheap way if you want, where you're like, okay, 32 divided by what will give me 2, right? So what number do you guys think should go over there? Amazing. Good. So just remember that trick, it comes in handy, right? If you wanted to double check, 80 divided by 16, is it 5? The 5 trick, I don't know why, like when you're a kid, 5 times tables seem so like easy to memorize up to maybe 10, but then it gets a little awkward. So what I usually do if I'm doing, and I've probably said it before, forgive me, but 80 divided by 10 I can do pretty quick. How many times does 10 go into 80? Well, 8. So shouldn't 5 go into 80 twice as many? So I just double the answer, 16, boom, there you go. All right, so just cleaning up for the next line. I'm just gonna scooch up my paper a bit. Hopefully you guys could still see everything nicely. 2x to the third. Then I'm gonna pull that 2x plus 5 out front, which is a linear expression inside. That means it's prime. That's a monomial there, so that's prime. But then we have this part that kind of made people feel a little awkward. 3x squared minus 16. And I bet a lot of you wish that one of the numbers in this part over here was a different number, right? That it was almost anything else. Come here, stop crying. Come, sorry. Which number in this expression do you kind of wish you could swap out for something else? To what kind of number? Right, because it's like so close to being that good difference of 2 squares, but it's like, not quite, and like, what do I do with it? So some of you, you have options. Some of you may have solved this by just setting that equal to 0 and taking square roots. That's fine. All good. Others could have gotten a little creative with factoring it. Common mistake though, there's a number that a lot of people wish was the square root of 3. I know that you wouldn't do this for another number, but when it comes to like non-perfect squares, you guys get very inventive. And people try to think that the square root of 3, what number do you think people accidentally say it is? Like they give me a decimal. What would you guess that people guess? Maybe you guessed it. What decimal yes, I see already 2, 3 people, 4 people, right. People think it's 1.5, but that's half of 3. That's not the square root of 3, right? Like the square root of 16 is an 8. The square root of 100 is not 50. So just keep that in mind because, you get a little inventive. If you get something like this in the future, square root of 3, where you don't know the square root, guess what? Just leave it as square root of 3. It's fine. That's allowed, okay? So if you were to factor, just going to a side spot over here, if it were this instead, 9x squared minus 16, and you had to factor that, how would that factor? Oh my God. Come here. You guys are meeting my dog right now. This is Dallas. He says hi. 3x plus 4, but you should have 2 factors for that, right? And Abby, I like your style. And she stuck a minus there too. Jackson, good. So 3x plus 4 and 3x minus 4. Good. So you would take basically, that's the square root to figure out what's to use. So the issue with 3 is it's not a perfect square, but that's okay. What is the square root of 3? If I asked you, what is the square root of 3? And you had to write it on your paper. And I'm just trying to type in the chat so you guys have something to copy and paste if you want. Oh, Sam, you got it to work. Nice. So if you want to copy and paste for a square root symbol, if you can't get one to work on your keyboard, they're in the chat. But it is square root of 3. That's fine. That is totally fine. It looks funny to you maybe, but it's fine, okay? So we're going to factor that. What was the magic word for 2 expressions that have the same terms but a different sign in the middle? Magic word for that. Beautiful. Conjugates. So I'm going to start with the 16. We said it just a minute ago. You guys told me the square root of 16 was 4, basically, because you did plus 4 and minus 4. You love my dog. He's being like, he just like wants attention right now. I think he's not used to me being home, obviously, during the day. So he's probably like, he has Christmas pajamas on. So he's like, I think annoyed that I'm talking. He's like, shut up. I want to take a nap. The square root of x squared we could still do, right? It's x. And the square root of 3, if you don't know it, you could just do that. Does it look funny? Maybe, but it's fine, okay? You, by all means, did not need to do it this way. If you thought it was 1.5, I'm not going to take off a lot of points. I take off like a point, right? Because you're trying. I get what you're doing. You made an effort, or some other decimal that you kind of concocted in your head. All fine, okay? As long as you follow through and you commit to that answer, right? Now, these are all equal to 0. Step 1 for solving a polynomial equation, get it equal to 0. Step 2, factor. Try GCF first. After you're fully factored, ask yourself, am I fully factored? Make sure you factor more if you can. Now what? Final step to finish a problem like this. I'm just going to kind of prep it onto another. Yep. Yep. Yeah, but we also have, I'm just going to kind of tilt that. Yeah, that one there too. So don't forget that. Now, factors are things that are separated by multiplication. So some of you, we might remember doing something like that at one point, but we said, does 2 equal 0? Like, is that even a thing? No. So we could just drop that. X cubed, remember, is x, or x minus 0 cubed. You take the inside only. We don't care about the power on the outside, that multiplicity right now. We just set that equal to 0. So really, you could just jump to that. Jay said 2x plus 5 as well. Don't use decimals. Show steps. A lot of you guys are like bringing 5 over and keeping it positive because you're rushing. Those little things, you know. Divide by 2. Leave it as a fraction. Don't do a mixed number. Leave it as an improper fraction, but reduce your fraction if you can, right? So Dennis even said we're finding the zeros. Exactly. Solving equations, polynomial equations, and getting zeros or x-intercepts are more or less the same process. The only difference when we're solving equations later on, we're also going to implement these things called imaginary solutions. Those are not x-intercepts, so there is a little difference between the two. Because you can't plot an imaginary number on your graph. But for right now, what we're doing, it's the same. So square root of 3, x minus 4 equals 0. Most books or teachers won't write it like this. They will write it instead like this. Why do you think we change it to this instead of that other format? Exactly. Yeah. And that tends to happen. I get it. We draw our square root symbols and then like you're mid problem and all of a sudden it like moved. Now it's under the radical or whatever. You confuse yourself. So we just stick it in front. Sometimes depending what I'm doing, especially like in a calc class, I put this little like, I don't know, like edge on my square roots just so I know like it's done. And another thing I don't do, I used to always put, you know, on a square root, some people do like a little extra line on the hook. I kind of don't do that anymore either because it starts to look like a negative and it gets confusing. So just little tidbits there. Now, we add 4. If you want to type in the chat, I know I've asked you before, but this way I could kind of figure out maybe a little bit better who you had for geometry last year and like maybe what level. So I could figure out which kids did and didn't do certain things last year that we start talking about with square roots and whatnot, because I find that, you know, we're going to have a couple gaps. So yeah, so you could say ESPO if you want to say if you had honors or regular geometry. If you don't remember exactly, like whatever you remember is great, okay? But if I divide both sides by square root of 3, we could definitely do that. We get something that looks like this right now. If you left your answer something like that, that's fine for now. Moving forward, we want to make sure we're implementing rules and procedures. If you remember anything about what the name of the process we need to do is called, or what we need to do, or if you remember what's not allowed, just tell me anything you remember about answers like this. That you remember doing maybe last year, probably in geometry. Do you remember there being a rule about the way this answer is written? Or good. We can't have a square root or cube root or any root really, but we can't have a square root in the denominator. Now, it seems like, well, what are you supposed to do? That's the answer. How do I get rid of the square root in the denominator? But the reality is with fractions, we always have more than one way to write them. So even, 2/3 and 4/6. If I was like, write me 2/3, but you're not allowed to have 3 in the denominator, well, it's the same as 4/6, right? Like you have some flexibility there depending on the rule. Who remembers, even if you don't remember exactly what to do, maybe you kind of remember, how do we handle that? What were you supposed to do to get rid of that? Go ahead, you can talk at the same time. We'll figure it out. Nice. Now, when you do that on top and bottom, and I like that you said that because a lot of people will just say out loud, multiply by square root 3, even though they write this on their paper, they'll say out loud the wrong thing, or they draw a giant square root 3 and they're like, oh, it's going to top and bottom. This, what you said, is perfect. What number are we actually multiplying by when we do this? Right. So 1 is something we call our multiplicative identity. We're always allowed to multiply by 1. It does not change the value of something. It just changes what it looks like. That happens too when we multiply across. Lesson 3, we did multiplicative, not multiplicative, we did operations with fractions, 2 or 3. So 4 times square root 3 is just 4 root 3. Square root of 3 times square root of 3. Some of you take a weird roundabout way to do it. But what do we get? Chat out loud, anywhere. 3. But some people will think like, well, square root 3 and square root 3 is square root 9. And then they start by just leaving it there. But remember, the goal is to get rid of the square root on the bottom. Well, what's the square root of 9? Oh, it's 3. What's another way to say a square root of 3 times square root of 3? Like, what's the other phrasing or symbol we use when we multiply something by itself? What do we call it when you multiply something by itself? Yeah, it's squaring. Good, could use thanks. So square root squared. What happens when you square and square root on the same step of a problem, or one right after another? What happens when we square and square root on the same problem? Or how are they related to each other? Remember, I don't care if you're wrong. I don't care if you use the wrong word. Right, they go away because they're inverse operations, squaring and square roots. So you just get what's inside. Now, there's always those sneaky exceptions. We'll talk about that later. But just remember, when you do this process, you just get the 3. No need to do all the extra work. You're basically squaring a square root. Next, what was I going to ask? Oh, what is the name of this process? Does anybody remember what the name of this process is? Yeah, rationalizing, and we're in this case, you're rationalizing the denominator. Nice, good. So the reason it's called that is this number of square root 3, when you can't take the square root of it, like we saw earlier, that's an irrational number. And when something is irrational and you want to make it rational, even a human, a person, you want to rationalize with them. So we call it rationalizing the denominator. So there's an answer. I know some people had like radical 192 on their paper, I think. And I think that happened because of not taking out a GCF or something and kind of doing it a long way. But it ends up, it would simplify to the same answer. And then I'm just going to fast forward a little bit. If we do the one with the plus sign, do you guys know what you're going to get for your answer for that one? It's the same factor, right? But one has a plus sign, one has a minus. Yeah, it's the same answer, just negative, exactly. So I'm just going to jump right to the negative. So negative for root 3 over 3. So we got this answer. There's 1. Here's the other one, 2. Here's a third one, 3, and a fourth one, 4. And actually, some people will be like, but I thought we needed 6. Remember, at most 6, but that was 1, 2, 3, 4. But really, 0 is an answer 3 times. That's what multiplicity also means. So it was 4, so then 5, 6. So you do have 6 answers. You just have 0 3 times. And that's what makes that squiggle in a graph. It's like am I going over the bridge or not? I don't know. And it makes a squiggle, okay? So that's the end of number 1. Did anyone recall that did get to finish number 1? Do any of you remember getting these exact answers? Or at least starting it and you were on track? You could hit maybe the hand raise button or type in the chat if you think like, yeah, it looked pretty similar. Well, we got 4. Yeah, so 0, like I said, it's just like a triple answer, but there's 4. But you definitely got part of it, right? This part maybe was the messiest for people. All right, so that's the end of this example number 1. I'll assign a new number 1 later. I'm going to stop this recording, and then I'm going to record number 2 in a separate video so that you could, like, anyone who needs to watch could just watch what they need to watch, okay?